Okay, in the previous example, we overloaded plus in equality and function core operators. We also learned that we could overload operators as non-member and member functions. In these sessions, we will overload more operators, including insertion and increment operators. And we'll talk about some of the things that you should be aware when you are overloading them. So let's start. We have been used insertions and extraction operators, which are this one, for console input and output. They are two different operators, and you can overload these operators so that you can use them to input and output object of the classes you defined. For example, here my object is the objects of money class that we defined in the previous sessions. And if we overload this insertion operator in a way that it can work with money class, then you can print the member variables, simply use the insertion operators like this. You do not need to call output member functions to print the values stored in these objects. So these two lines, this line and this line, will produce the same output if we properly overload these insertion operators. Same for extraction operator as well. If you overload this extraction operator in a way that it can work with money class, then you can directly store users' inputs to the objects using this extractor operator, so as shown in this line. In the previous example, we use input member functions to store the values into these objects, but if we overload these extraction operators, we can directly store the user's input using this extractor operator and scene objects like this way. And overloading insertions and extractions operators are not that different from what we have already seen for other operators. Let's first overload insertion operator, this one. Insertion operator use cout object as a first argument, and there is a second argument as well. So if you look at this one, this is insertion operators. The first argument is predefined object cout. It is defined in IOStream library. And the second argument is a string literal, as shown here. So if you look at this line, this is an insertions operator. The first argument of this insertion operator is this cout objects, and the second argument is a literal string. So insertion operator is a binary operator because it receives two arguments like a plus and minus and multiplications and so on. So this means that you can overload insertion operator just like other binary operators. But one thing that you should aware is that you cannot overload insertion operator as member functions. Why is that? We learned that we could overload the operators using member and non-member function in the previous sessions. But for these insertion operators, you cannot overload insertion operator as a member functions. So what is that? If you overload the operator, the insertion operator as member functions, then the first operand, the first arguments would have to be the calling objects, which will be the class type money. But the first operand should be cout, as shown here. If you overload the insertion operator as a member function, you cannot make the first operand as cout. So you should overload the insertion operator as standalone as a global functions. We will overload the insertion operator so that it works with our class type for the second operand. The first operand should be cout objects, which is a class type OS stream. The money class has output member functions, which prints the dollars and cents stored in the objects. So if you do not overload the insertion operator, you have to implement code something like this way. This code prints I have string first by using the cout and insertion operators, and the actual amount of money stored in the objects, in this object, amount is object of this money class type. So the money stored in these objects are printed through these output member functions. So these two lines output will be I have something that prints by these output member functions. But as you can see here, this styles of programming looks very strange. It is much nicer, it's much better to print with a single line like this one. Printing amount of money stored in this amount objects like this way, single line is much better than these two line. So this one single line and this two line produce the same output, but this one looks much better. But in order to print this amount objects using this insertion operator and cout objects, you have to overload this insertion operator so that it works with this class type you define in this example, the money class type. So that is the reason why we are overloading this insertion operator here. Then we are overloading insertion operator so that it can work with our defined class type as shown in this example. What should be the return type of these overloaded insertion operators? That is the one thing we should consider when we are overloading these insertion operators. So what should be the return type of this overloaded insertion operators? We are overloading this insertion operator so that we can use the objects of type money class. If you look at these two lines, these two examples using cout and insertions operators, these two lines produce the same output. The only difference is that the second line has these brackets. Both this first line and second line will print I have and some value stored in this almond objects. And these two lines both uses the cout and insertion operators. So depending on how we overloaded the insertion operators, the different output will be produced. But these two lines will produce the same output. So they are equivalent. Both lines evaluate, so this one, the first and second line evaluate first this one, cout, I have string. So this one. This will be evaluated first for these two lines. And after that, these two lines perform these second evaluations, cout and almond. It prints the almond of the objects using these insertion operators. And in order to evaluate the second line, the first evaluations must return cout objects so that it can be used for evaluating this second line. So this one is the first evaluations. And in order to evaluate the second one, which is this one, the first evaluations, this one must return the object of the cout objects, so that we can use that cout object to evaluate this second line. So overload insertion operators should return cout objects, which is a class type of OS stream. We have to, the insertion operator have to return the cout object so that it allows cascade evaluations, like as shown in here. This is the example code of showing overloaded insertions and extractions operators. Let me explain this code using a terminal. So this is the example code. Let me compile this program first and see the output. Okay, this program asks me to enter some money here. Let me see the main function first. So if we look at the main functions first, it's declaring the money types of class variable. The money class is defined here. It has a constructor and has a member functions, and it's overloading these insertions and extraction operators. It's using a friend keyword. We haven't learned friend keyword yet. We will gonna learn this keyword in the following sessions. And this class has two member variable, which is a private, and it also has a private member functions as well. So this is the constructor of this money class, and this is the definitions of member functions, get amounts, get cents, and get dollars, and so on. And here we are overloading operators, equality, minus, and plus, and here we are overloading insertions and extraction operators. So this program asked me to enter an amount of money because of this line, and it's waiting my inputs here. As you can see here, because we overload these extraction operators, we could use these objects as a second operand. This object is a type of class money. So let me put some number here, 1, 2, 3. If I put 1, 2, 3, it prints no $sign in money input. It's showing error message and terminates it. That's because we overloaded insertion operator here. When I entered this 1, 2, 3 number, overloaded insertions, the extraction operator will be invoked, which is this one. And if you look at here, the first argument is input stream, which is a scene, and the second argument is money types of object, which is this one. And it's using this scene. We pass the scene here, so scene to receive user input and stores that user input into this variable, which is this one. And if that variable does not have this $sign, this error message will print and terminates the program. And because I did not enter these $signs in my input, so the program prints this error message and terminates here. So for this time, let me put the $sign here so that I do not fall into this error message, 123.45. If I enter this number, obviously, like previous executions, the program goes to here. Program control goes to here, and the so if you look at the output of the program now, it's printing a lot of things here. First of all, here, this one is from here. As you can see here, your amount is object, which is a class type of money. Because we overloaded this extraction operator, we could use these objects as an operand to these extraction operators. So if we look at the overload the extraction operators, what it does is it received the dollars, it obtained the dollars and cents from the second argument, which is objects of money type. And it prints dollar depending on the obtain the dollars and cents, it puts a negative value, the minus signs or not. So it just prints the shown here, dollars and cents. And yeah, in this one, because we overloaded the minus operators, we could perform the minus operations using these objects of type we define, which is a money, and we can also perform the plus operators, plus operation using these plus operators for the objects of type we define, the money. So like this, by overloading this insertion, extractions, and plus, minus, we can use these operators for our class type, which is a money, shown in this example. If we did not overload this extractions and insertion operators, you cannot use these objects with the in and extraction operators in these objects by using cout and extractor insertion operators. So this is how you overload insertion and extraction operators. And as we can see here, insertion operators return, this one is an insertion operator. Insertion operator returns the output string that we received as our first operands. And the extraction operators returns the input stream, which we receive as the first arguments. We are returning this output stream and input stream so that it allows cascade operation as we saw in the slides. So let's go back to the slides. So we just saw this example code overloading extractions and insertion operators. You can also overload assignment operators. Assignment operator is this one. But there is something that you should know when you are overloading this one. Unlike insertion operator, that you should not overload it as member functions. If you overload the assignment operators, you must overload it as member functions or member operators. The member functions and member operators are same in here. So insertion operator and extraction operator, you should not overload it as a member functions. But for these assignment operators, you have to, you must overload it as a member operators. If you do not overload the assignment operators, you will get deferred assignment operators. This deferred assignment operator will perform shallow copy. We learned shallow copy and deep copy when we were studying constructor on week 9. For the simple classes that does not have pointers or dynamically allocate memory, shallow copy works just fine. So you have no problem using deferred assignment operator for the case. But if the class has a pointer, member variables, or if the class uses the dynamically allocate memory, the shallow copy may cause unexpected result. So you should overload it assignment operators so that it performs the deep copy. If you are not clear about shallow and deep copy, please look at the week 9's lecture notes. And if you want to overload increment and decrement operators, which is this one, plus plus or minus minus, you need to aware that there are prefix and postfix notations for these operators. The prefix notation is this one, and postfix notation is this one. I'm sure that you have already learned the prefix and postfix notations in C programming course. They use the same operators, plus plus or minus minus. The only difference is that whether it comes before or after the variable, as shown in this example. For the prefix notations, the operators comes before the variable name, and for the postfix notations, this operator, the plus plus operators, comes after the variable name. And because they use the same operator symbol, so for example, even though whether it is prefix notations or postfix notation uses the same operator symbol, the plus plus. So you need to somehow able to distinguish between the prefix notations and postfix notations so that you can overload it, this plus plus operator accordingly. The way to distinguish them is to add int type of second parameters. If the overloaded increment or decrement operator has its int type of second arguments, then that overload operator is for the postfix. Otherwise, the overload operator is for the prefix. So as shown in this example, because they both overloaded operator plus plus, but the below one has a int type of parameters for the second arguments. It is for the postfix. Note that int type is for the second parameters, not the first parameters, because this operator is overloaded as member functions. So we learned that in the previous session that if we overloaded operator as a member functions, the calling object will be the first arguments to the overloaded operators. So the calling objects, which will be the money types of objects, will be the first operand, and this int will be the second operands of these overloaded operators. Anyway, because there is an int type of parameter here, this plus plus operator is for the postfix notations. And because there is no int type of operand here, this overloaded operator plus plus operator is for the prefix notations. So you can distinguish them by putting the int type of parameters for the second operand. This is the things you should know when you are overloading the increment and decrement operators. So let's look at the assignments and increment operators using a demo code. So this is the demo code. Like a previous example, we are using the same class, the money. Let me compile this program. So here we are overloading assignment operators and increment operators. This one is for the postfix because of this int type of arguments, and this one is for the prefix. And inside of the main functions, first of all, we are declaring the class variable amount. So the object objects of type money will be created here by using a 10 integer value. So let me compile this program. I think I've already compiled this program. If I run this one, this program produces this output. Let's walk through one by one. So A is $10 is printed because of this one, A is, and then $10, $10, this one is printed because of calling this output member functions using these A objects. Okay, so A has a $10 because this statement copies the value stored in this amount objects to this A, and because amount is created using the integer value 10, if you look at this constructor, this will invoke the constructor which will receive one argument of int type. So this one will be invoked. So the 10 will be passed here, and this 10 value will be used to initialize the dollars member variable. So these dollars will be set to 10, and cents will set to 0. So that is the reason why A stores $10 because amount object stores the $10, but if you look at this one, there is an increment operator. So we have already overloaded this increment operator. This is a postfix version, so this increment operator will invoke these overloaded functions. As you can see here, okay, so it will increase the dollars and cent by 1. So these dollars will be 11 because the money which is this one will amount was originally 10. So this one ten plus 1 equals 11. So here dollar stores 11 and cent will store 1 because originally it was 0 because but we are increasing by 1, so the cent will be 1. So this will create new objects, which is dollar is 11 and cent is 1. And returns it. But this, as you can see here, the amount of dollars is increased by 1 and cent is increased by 1. So after these statements, A will store the $10 and amount will store $11.01. So that is the reason why here amount is this one and amount value is 11.1. So $11.01 because we increased by 1 here. And here we are here the assignment operators, the overloaded assignment operator will be invoked, which is this one. It's creating new objects by using a 10 integer value. So these objects will hold $10 and this object is passed to this assignment operators. So here if you look at the definition of the class, as you can see here, this assignment operator is overloaded as member functions of this class. So this is a second operand, which is this one. So this the money object stores the $10 and 00 cents because we create the objects using this just one integer value. And the calling objects will be the first operand, which is amount. So this one will update the dollars member variables of this amount objects. So if you look at this one, the money is a second operand. So we are getting the dollar stored in this second operand, which is a $10. So this function call will return 10, and 10 minus 1 is 9. So dollars of this amount object will be updated to 9. And we are printing amount output here. So originally amount was $11.01, but because dollars here is updated to 9, so this output function call produce this number, the 9, because we update here, but here we did not update the cent, so the cent remains same, which was 0.1. And here we are using increment operators. This is a prefix notation, so this version will be invoked. Dollars and cents of the amount objects will be increased by 1, and using that value to create the new objects and returns it. So and that object is assigned to this A. So the assignment operator, the invoke assignment operator will be, the overloaded assignment operator will be invoked here as well, this one. And as you can see here, because we increase the amount of the objects using this these operators, overload operators, dollars and cents of this amount object will be increased by 1 because of this one. So amount was originally $9.01, but because of this increment statement, dollar is increased by 1 and cent is increased by 1. So that is the reason why it prints $10.02. Okay, so as shown in this example, by overloading these assignments and increment operators, prefix and postfix versions, you can work, you can use this operator with the objects of type that you defined. Okay, so that's it for these sessions. See you in the following session. In the following sessions, we will talk about the friends keywords, and I will summarize this week's lectures.